All right, for these, I'm going to give you the setup of the equations, and you're going to actually solve the system equations yourself. I'll just show you how to write these, so that's what these videos will do. Okay, um, these are situations where you're dealing with a business. It says business here. A business is paying some money out for their costs, and then they're bringing money in for their income, and then we're looking for where they break even. So a bicycle store costs $2,400 per month to operate. So this is going to be one of those costs, and that's going to happen once a month because they're asking about each month. So if we're talking about each month, then that will be a one-time thing, that $2,400 per month. So then the store pays an average of $60 per bike. Let's do this. Let's define the variables, okay? So we can say X, oops. So actually I'm going to type it, and we can say let X equal the number of bikes sold. Okay? Or just number of bikes. Let's say number of bikes, because we're going to use that for sold and for bought by the store as well. And then let's define the other variable. Let Y equal the total amount in dollars. Okay, by defining the variables like this, you can then know what it is that you're using for X and Y, and we can keep everything straight. So we've got this cost of $2,400 per month, but then there's also this cost of $60 per bike on average. So if we wanted to write the total amount Y that the store had to spend on what they need to run their business, we would say that they are going to pay $60 for every bicycle, and the bicycle, as you can see up top, is X, the number of bikes, and then they will have to add a one-time cost per month on of $2,400. So that's one of their equations, one of the equations for this. And the other equation then will be, okay, now let's say the total amount money in terms of, in this case, money brought in will be, well, how much are they bringing in? Their average selling price for each bicycle is $120. So that says you will bring in $120 per bicycle. Whenever it's a per bike kind of situation, each bike happening for every particular item that's sold or used or whatever, that will be a coefficient on a variable, and the variable means that will represent the total number, and then this is the what do you do for each. Here you bring in 120 for each, here you pay out 60 for each when they're selling it. Yeah, and then you could use substitution, you can use whatever method you choose, and you will solve it the way that I think that you know how, but that's the setup for how you do this. And one of the first things you need to do is you want to define the variables, tell what the variables are and what they represent. And actually, I've decided that I'm gonna go ahead and I'm gonna solve this problem for you. Why not? Okay. Let me erase this and move it up. Y equals 120x. And let's just solve it. Okay. I'm going to take the original equation up top, or one of the original equations, x. Well, actually, I don't need to rewrite it like this. They're both equal to y, so I'm going to write them equal to each other. 120x equals 60x plus 2,400. Subtracting 60x from both sides, you get 60x equals 2,400, and dividing both by 60, you get x equals 40. And x is the number of bikes. So how many bicycles must the store sell each month to break even? 40 bicycles. And of course, they didn't ask me for the amount of money. I could plug it in and find out what that is. And in fact, if you did that, let's do it over here. Y equals 120x. We can say then y, what is that amount of money? Equals 120 times 40, or y equals 4,800. But that's not what they asked for. We know what y is, but they're really just asking for the number of bicycles, and so the solution